something, but at first I will not say what we're gonna learn. I will show one activity by our student, and by observing that activity, you, my student, will discover that which one today we're gonna learn. All right? Okay. So that's really great. But before that, I like to already have distributed. Over here, you can see that 4 teams we are having. Can you please raise your hand for Team Einstein? Albert Einstein team. Yes, right. That's great. Everybody please give a good clap for them. So they are Albert Einstein team, and they will work together for today's activity. Then after that, Team Newton. Can you please raise your hand? Team Newton, right? Yeah, so they're really, really great. So these are the team Isaac Newton, and they will also work in a group for some activities. Then Team Marie Curie. Team Marie Curie. Yes, right. So there's the dynamic group, and then last one, that James Clerk Maxwell group. Can you please? Yeah, right. So that's really great. Make it on that side. 90-degree clockwise. That's really good. So over here, we're having 4 teams, and they will work together, and they will discuss among themselves to find out, to discover today's topic, the lesson objective. Now let's go to see this one that is called magic rod. This is called what? Magic rod. Or its another name is that fun fly stick. Okay, so by using this fun fly stick, I'm going to do something, and you will try to find out that what's today's topic, what's today we're gonna learn. So ready, steady, and go. Look, I'm doing something, right? Any student, can you please come? Any student? Just me? Can you just come? Hold it. 1, 2, 3. You're right? Now team, all 4 teams, just discuss among yourselves and try to find out that what is today's topic. Today, what we're going to learn. Please keep going. You're right. What is today's topic? Which one today we're going to learn? Yes, electric field strength. That's really great. Electric field, you can come at the middle so that everybody can see it, right? So electric field strength, or even electric field lines. You can see over here, give it to me, yes. Okay. While I am pressing, from here some invisible something is getting out. Right? Yes. And because of that, this one that is flying. Okay? So these invisible lines, we can't see it, but we can feel it. So from here we can understand that today's lesson objective, that is electric field strength. So please note it down, everybody. Just check your notebook and note it down, that today's topic. So today's topic, today's lesson objective.
Mr. 陈一子先生刚才是通过那个魔法棒的实验，通过做那个魔法棒的实验，让学生猜测今天这节课的主题是什么。然后学生猜测了这节课的主题应该是电脑强度。然后他现在给了是这节课的教学目标。第一个是他这节课主要的教学目标就是电场强度的定义。
Yeah, so thank you. Students, please write your lesson objective for today, the electric potential difference. And then the last one, that is today's main topic. This is the main topic for today, the electric field strength.
前边2个是电场的回顾以及电势差的回顾内容。
So there we are. So these 2 are reading. Already we learned. Students know about these 2, and this is today's topic. This is the main topic for today. We're going to learn about electric field strength. And before that, we need to know about this electric field and electric potential difference. Because of these two, we can find the electric field strength.
这节课我们已经学过前两个了，所以主要是想通过前两个定义来找到电场强度的定义的。
Electric field. The changed property of space is called an electric field.
So this is the listening one, right? So try to listen at first again.
Electric field.
Electric field.
The changed property of space is called an electric field.
The change property of space is called the electric field. You have seen today that whenever I like to press it, on that time, over here the space is having some change, right? Something is going on over here, and because of that, this one that is flying. So if there is any change on the space, so that means that is what? The electric field line. So the next topic for the electric field line.
Electric field line. The line used to represent the actual field in the space around the charge is called an electric field line.
Now the electric field line means there are some invisible line which is really acting over here, right? Yeah. So now I like to request 3 boys and 3 girls. Can you please come over here to just stand? Please come. One from here. One. Please come. Yes. All right. Flora, you can come from here. Please come. Yeah. Well, 1, 2, 3 boys come this side, and more 2 girls. Can you please come? Yeah. All right. So the girls are, although the girls are not negative, but I will give. Can you just wait?
他现在 Mr. Shahid 先生现在给学生发的这个纸牌上边分别带了正电荷和负电荷，男生所有带的全部都是正电荷，女生带的全部是负电荷。
Fine. So you can see over there some charges, right? Can you go a little bit back so that the audience can see? Yeah, okay, right? Okay, right. Okay. So you can see that we're having some charges. Okay, right? And where's our test charge? So over here, what we are going to do, that you can see that these lines, they are positively charged plate.
Yeah.
They are positively charged plate, okay? And they are negatively charged plate. Myself, I am a positive test charge.
Okay.
A small charge, and they are so big, isn't it?
Yeah.
Now, if I like to go inside, then I'll feel some what?
Just
Some
force.
force, right?
Yes.
And because of the force, so the positive, I'll go to the negative side.
Yes.
Or I'll just start to move to
Around
one side, right?
Yes.
So if I like to come straight, so I must go in this side. Isn't it?
Yes.
So towards the negative side, I need to move.
Yeah.
Why?
Yeah.
Because
Same
the
sign.
in the electric field.
Yeah, right. That's really great. That means this is an electric field which one they are producing. Now I can draw these lines. Can you just take it one? Hold it from here 1 to 1. You're right. So can you see that? What is this? Yes, right. Oh, straight. Yes, right. Straight, make it straight. Yeah, right. Make it parallel, and straight. Yeah, right. Okay. Make all these 3 lines parallel. Now we can make this one is what? Uniform electric field.
Yeah.
Isn't it?
Yeah.
The uniform electric field. And these are what?
Electric
Electric field lines. And this one is what?
The
Test charge.
Yes.
If I like to keep on, if I like to come towards it, so I will exert more force. If I come more force, isn't it?
Yes.
If I come more force.
Yes.
And if I like to go back, so the force will be very less.
Yes.
Right?
Yes.
After some time, there will be no force. I'm free.
Yeah.
Right. So that means over here, we got the concept. So this is what the electric field lines. The one which one you created, that is what? Electric field. Yes. And this is a charge. Whenever this charge will go inside, then it will exert a force. Which one will give us electric field strength? And that is today's topic, electric field strength. Do you understand, boys?
Yes.
Girls? Is that all right? So thank you very much. So go back to your place and you just keep it over there. I will call it again.
Yeah, what about it?
Yeah, keep it with you. I will just call it again. So hope so you understood the concept about the electric field lines, and electric field strength. So please speak English in between. Now here is one quiz for you. So any group, okay, you just discuss it on yourself for 10 seconds. And then after that, you just raise your hand and which one who can say the answer. So what is the electric field over here? You can see that 4 answers. The change in the properties of the space, the change in the properties of the space that surround any electrical charged object, or C or even D. You just read it and take your time for 10 seconds, discuss among yourself, and raise your hand. Any group. Yeah, Nora? B. Okay, let me see that. Yeah, so it's a, give a clap. That's really good. That B is the answer for this quiz, right? So that is Marie Curie group. So Marie Curie group got 10 points. So at the last, we will decide that which group will be the winner. Okay, all right? That's good, yeah. Now the electric field lines radially pointed outward. So see over here, there's a placard. You can see that, it's a placard, right?
Yeah.
So over here, I'm trying my best to explain you that how these lines are coming out. Few minutes back, we have seen that for the parallel place, how the electric field lines are going on. Now over here, if that is a small charge or even a round charge, right? So from here, how the lines are coming out. So we are telling that that is radially outward. What? Radially outwards, right? So look, all these lines are radially outwards.
Yeah.
But here's the problem. The problem is that you can't see this line.
Yeah.
Like at all.
Yes.
I will show you the line. I will make a magic now. Like, all right?
Yeah.
Now I will show these lines to you that really these lines are existed in this world. Right. So let's see that. I will just request, can you please just close this all curtains? Miss May, please come. Miss May, start.
Mr. Shahid 刚才是让6个学生站到中间，6个学生代表了不同的电荷，他通过让学生拉线来用来代替电场线。他手上拿的那个电荷呢是试探电荷，在这个电场中试探电荷会受到力的作用。他又拿这个但是通过学生拉扯线不知道这个电场线的方向是朝着哪儿的，他又制作了一个纸牌用来标注这个电场线的方向。他又给学生提的问题是。电场线刚才在2个实验中我们都是看不到的，但是现在他通过一个魔法球想让学生来看到电场线。
Right, here we are. Now you can see the line, electric field lines. See that he's touching.
Yeah.
Can you see the electric field lines?
Yes.
Yeah. So we can see the electric field lines. And even the electric field strength, isn't it?
Yeah.
So if I like to give another one, you can see now the 2 electric field lines.
Yeah.
So which is very much matching with this placard. Over here, look. This is the point. That is the point. And all the lines are coming out. You can see it in your book, right?
Yeah.
In your physics book, you can see it. Now, reality is that. Really, that thing is going on. Okay. So from here, we can find out the electric field lines. Now, see some more fun and some more magic. Yeah, it's all right. You move your hand. Come here. Okay. Now, this is a light, rod light, right?
Yeah,
Tube
rod.
light. Now, if I like to teach you, look. Ready? Ready? It's a magic. Ready? It's going on. It's going on. It's going on. Can you see that?
Yeah.
So, how this thing is happening?
Magic. It's physics.
It's physics. Yes, right. That's really good. So while I'm touching, look, over here, there is no charge. This
Yeah.
point. Okay, right?
Yeah.
Because I'm touching, that means through my hand,
It goes to
the
the
electricity goes to my body. So over here, my point is what? The neutral.
Yeah.
And the positive one is this one.
Yeah.
Because it is having the positive charge.
Yes.
Right?
Yeah.
So whenever I like to just touch it on that time, those positive charges are coming over here, and it is producing what, some lights.
Yes.
Okay, that means over here we can get some concept of electric potential difference. Over here we are making some difference, isn't it? In between these 2 points we are making some difference. That is the electric potential difference. So this is electric field lines. This one is electric potential, isn't it? Electric potential. Okay, right? Or even if I like to over here, right? Full. So this is what? Electric potential. So in between these 2 points, we have created some potential difference. Potential over here V1, that is V2. If you like to subtract V2 minus V1, we can find out what? The difference. Potential difference. Now what is electric field strength? Now see the electric field strength. Ready? Steady, go. Look, it's so bright. It's dimmer. It's dimmer. No, it's nothing. Means what? The electric field strength. Over here, no electric field strength, isn't it? While I'm coming back, electric field strength is increasing, then increasing more, and even the most. Right? So today at the beginning, the positive test charge means, right? Whenever I have gone very near to your field, the boys and the girls, okay, right? I am feeling more excited, more force. So that is really proved. Are you getting the points? So from here, from this demonstration, that is called plasma globe. What? Plasma globe. Yes, right. So this is called plasma globe. So by using this plasma globe, very good way, we can see picture. We can make a picture. We can see in our own eyes all these 3 topics about the electric field, electric potential difference, and electric field strength. Do you understand? Any question? No. Okay, thank you. Go back to your seat, please. Please open the curtain.
Mr. Shahidur 用这个魔法球来解释了，用魔法球以及这个针管的实验解释了这个电视差的这个定义，以及引出了它对应的电场以及电视差和这个电场强度之间的关系。
Thank you, sir. Yeah. So we learned that from the plus, positive, all the lines are going out. Already we learned about that. And from the minus, all the lines they are coming inside, right? So now we can get some matrix movie, small movie clip. How really it works.
An electric field is a disturbance in space. It exists at every point in space, regardless of whether there is a test charge or extensive. And
So
the
we
phase
can see
action
that.
helps visualize the field. These field vectors reflect the symmetry of the charge.
Now look, there is a symmetric picture. So this full one, that is one electric field. And if we like to keep one test charge over here, you can see that how the lines, the electric field lines really works. Okay? Now if I like to go a little bit more further apart, see over
With a
here.
positive charge, the field is directed
Now
outward.
look, the two charges together.
The field is directed inwards.
So how it looks like?
The field gets weaker much more quickly than when I was in that charge.
Okay, so how it can even see that this is the real picture of the electric field lines. If one is plus and one is minus, then how the electric field lines are really it looks like. Okay? And this one is created on this space, in this free space. But which one we can't see, but we can feel it. Right? Okay, that's really great. Thank you very much. Now move on for the next quiz number 2, right? So I'll give you 10 seconds time. Now read this question and try to find out the answer. An electric field is measured using a positive test charge. Now this test charge experiences a force at an angle 30 degrees south of east. So the direction of positive test charge, it will be the direction of electric field lines or not. So you say about that. So just yes, the other group, yeah, you can try.
It should be A, the first one.
A.
Yes.
What do you think? Other groups? Yeah. C. Yeah. This group. A. What about you? What do you think? C. Okay, let's check the answer. But before that, I want to clarify you that the answer is A. Okay, all right. So the answer is A. The direction of positive test charge is the direction of electric field lines. So this is the positive test charge, right? So if the plus and number, can you come again, plus and minus quick? Very good. Yeah, right? Yes, no, very good to understand here, right? So plus and minus. So if we are having the two parallel metal plates, and if we can create a uniform electric field, then this positive charge, which side it will move, that is the direction of electric field lines. Okay, right? Already we know that the electric field lines are going on through it, right? Even the positive charge is going on, moving on to which side? That is what? The electric field line side. That's great. Do you understand now? Is it clear to you? So over here the answer is right. So can you please go back to your seat? Now, how can we measure the electric fields? So now we're going to learn about that how really we can understand the electric field strength. So now the mathematical expression. So I will just request you, that all students, please write it to your notebook. The electric field strength over here, E, that is represent force divided by charge. So E equal F divided by Q, right? So where the unit for F, that is Newton, unit for Q, that is Coulomb, and unit for E, that is Newton per Coulomb. Alright? So we will use it for our further mathematical calculation. The next part is for the electric potential. So how even we can learn about this electric potential? So we know that electric potential already equal to F by Q. So from here we can find the electric potential difference, that is del V equal to E divided by, del V equal to E into D, right? So please note it down over here. That electric potential difference, that is del V equal E multiplied even D. So from here even we can write the other formula, that E equal to V divided by D. It can be written down equation to find out the electric field strength. So at first we got the concept, what is with this theta. Now we are going to learn the mathematical expression. Okay, so the next point is equipotential. It's really important. Equipotential surface.
Equipotential. Whenever the electric potential difference between two or more positions is zero, those positions are said to be at equal potential.
Okay, I think you can hear it, right? Yes. Can you hear that? Okay, so the equipotential, right?
Whenever the electric potential difference between two or more positions is zero, those positions are said to be